We will work on 13.4 today. That's the cross product. Let's go back to the page. So this is section 13.4 and is cross product. And I mentioned it last time how this product, so I already gave you a little bit of an idea, but today we'll really get into it. Essentially, this is a product which is different from the dot product in the sense that you do the cross product of two vectors and you end up getting a vector. So this is a product that takes two vectors in R3. It only works in 3 dimensions. And the result is another vector. All right, be careful about this because that wasn't the case with the dot product. Warning, recall that the dot product is not a vector. It is a scalar. So in that sense, this is different, right? This is going to be a different type of product. So like I was introducing to you last time, what is going to be different is that we're going to have, hold on just a second, let me bring the book. So we're gonna have a vector, and to give you an idea of what vector it is, I need to tell you two things. I need to tell you what is the direction this vector is pointing and what is its magnitude. So we'll start with the magnitude because that's the easiest thing. So what would be the magnitude of this cross product? That's actually not a difficult thing to get. Let me just hold on for a sec. Let me access the book. Okay, it's getting there. So we need to know two things. What is its direction? And we use a cross to denote it, hence the name dot product. So what is the direction of U cross B is the first thing we want to know. And the other is what is its magnitude. Let's take a look at the screen. So this is what I want to know, right? What is the direction of the vector and what is its magnitude? And like I was telling you, this is how we're going to denote it, U cross B. Okay, so we'll start while the book loads. We're gonna start with the question of the magnitude. So the magnitude is easy. So what is the magnitude of the vector U cross B? And this is easy. The magnitude equals, remember that's how we denote magnitude, with the bars. And here's what it is U, magnitude of U times magnitude of V, our vectors, times sine of theta, where theta is the angle between the vectors, right? Now it looks a lot like the dot product. Well, remember with the dot product, here we had cosine. Okay, so the first thing you should note here is what's going to happen if this angle is 0, if my two vectors are parallel, right? So note that if U and V are parallel, remember parallel means one of the vectors is a multiple of the other one, and in that case the angle between them is either 0 if they point in the same direction, or pi if they point in the opposite direction. So if that happens, theta is 0 or theta is pi. But what is the sine of 0 or the sine of pi?
0.
Yeah, right? The sine of 0 or the sine of pi will be 0. So then the magnitude of the vector will be 0. And if the magnitude of the vector is 0, then it has to be the vector 0, 0, 0. In this case, sine of theta will be 0. Doesn't matter if we get 0 or pi. And so you proceed is the vector 0, 0, 0. Right? So in case if you have two vectors that are parallel, then the cross product is just 0, 0. Right? So okay, now let's see if I can show you the book now. All right, so we talked about the magnitude, and there's another thing we should note, and is that this magnitude has a numerical equivalency. So I'll show you that in just a moment. This is not going to load apparently. So let's go back to the page. Okay, so the other important thing to note is that if you do the following diagram, right? If I make the vector u, remember these are in 3 space, right? In 3-dimensional space. But even if they're in 3 space, when I look at 2 vectors, those 2 vectors will be on some plane, right? Even in 3-dimensional space. So let's imagine for a moment that my 2 vectors are my orange pen and my purple pen, right? Even if they are in 3-dimensional space, there is some plane where they both belong, right? And that's the drawing you're seeing right here, okay? And then this is the angle between them. And then what I wanted to let you know is numerically, what is this quantity, right? Where is this number appearing in this picture? Magnitude of u times magnitude of v times sine theta. And here's one place where this appears. If I look at the projection of v onto u, and I don't want the projection, I really want this height, right? This height. What is that height? Well, let's do a little bit of trigonometry here, right? If we do a little bit of trigonometry here, what is the sine of theta in this right triangle? Well, it's the opposite divided by the hypotenuse. So that's the opposite is h, and the hypotenuse is magnitude of v. So that means that my height is magnitude of v times sine theta, right? And then this magnitude that we have on top, the magnitude of u minus magnitude of v times sine theta, so the magnitude of the cross product, is like this number times u, right? And I don't know if you realize, but that's exactly what we would get if we wanted to know the area of this parallelogram, right? If you do this parallelogram, the parallelogram with sides u and v, to get the area of a parallelogram is base times height, correct? And what is the base? So the area of a parallelogram is base times height. And the base is magnitude of u, and the height is h, which we calculated. So if we put it all together, the area of a parallelogram is magnitude of u times magnitude of v times sine theta. That's exactly the magnitude of our cross product. So that's exactly the magnitude of u cross v. All right? Okay, let's see if we can finally see the book. I think we can now. All right, so right here at the very bottom, we have we're gonna have our definition. Okay, so here's the definition of the cross product from the book. And this is the first part where we were talking about. So here is the magnitude. The magnitude is the magnitude of u times the magnitude of v times sine of theta. and where theta is the angle between U and B. And so the part that we haven't talked about is the direction, right? So what is this direction of this mysterious vector cross product, U cross V? Okay, so that's the next important thing we want to talk about. What is the direction? And for that, the way we're gonna figure out the direction is we're gonna follow the right-hand rule. Okay, so the right-hand rule is you take one of the vectors U, you point in the direction of B, and then wherever your thumb points, that's going to be the direction of U cross B. All right? So we're using the right-hand rule. And I'm going to show it to you. Let's hope that this doesn't crash. So here's a little example of how it works. So right now I can specify right here in my little Mathematica code that I wrote to explain it to you. I'm gonna do the cross product of U and V, where I have these two vectors, and I'm gonna make them easy. One of them is gonna be say -2, 0, so that you see this guy is gonna be right there on the XY plane. And the other one will be something like, let's say, 3,5. All right, so the first one will be red, the other one will be blue, and the answer will be the purple one. Okay, so here's the answer. Okay, and now let me rotate it a little bit so that you see back. Okay, so the red one is the vector 1, -2, 0, right? It's a tiny one. And the blue one is a vector 3, 5, 0. And I hope you can appreciate there how the purple one is perpendicular to the plane that has the two of them, right? So we go from one of them, start from the red, go towards the blue. So from the red to the blue, and then where is your thumb pointing? That's where the purple is going to go. So the purple one will be perpendicular to both, from the red to the blue, right? So you can see that the purple points in the direction of the z-axis right now. So easy, it's a vertical one, right? But that's because I put two vectors in the xy plane, right? Both of my vectors are on the xy plane. So if I pick another one here, say, instead of 3, 5, 0, let's make it, let's actually flip them, right? What if I make this one, I want to show you something. I want to show you what happens when you reverse the order. So I'm going to move this one. This is going to be U now. And V is going to be the other one. And if I do that, look now what happens. So I just changed the order of the vectors, right? So now the red is blue and the blue is red. And as you can tell now the answer is a vector that points down, right? And that's because if you do the right-hand rule, this time my hand should be looking like this, right? And I'm going from the blue one to the red one, and my thumb is now gonna be pointing down, right? From the blue one to the red one, and then means from the red one to the blue one, from the red one to the blue one, and then my thumb points in the down direction. Okay, so that's the important thing, and it seems difficult, right? You may remember when we were doing the cross product, it actually was quite difficult for us to figure out the cross product just with this given angle between them. And here this is even harder, right? So the magnitude is difficult to calculate. We need to do magnitude of U times magnitude of V times the sine of the angle. That's one thing. And also the direction seems super crazy, right? I mean, it's in 3 space to begin with, which gives it an extra level of complication. And so we're gonna find out better ways to get this. All right. So let me try to restart the cameras. This is our definition of the cross product that we were looking at, and this is an illustration of how you go with the right-hand rule. So you go from U to V. So you're starting in this direction of U, you go towards V, right? So from U to V, and then you see where your thumb is pointing. You can see the example with the hand here, and that would be the direction of U cross V. All right. And now let me see if I can show you the other things that we were talking about. So we have this page over here. So we did this part about how it relates. The area of this parallelogram happens to be the magnitude of U cross V. So if we wanted to know this area of this parallelogram, we could do it with the magnitude of U cross V. All right. So how are we gonna figure out this cross product? And to begin with, let's do an example. So this is example 1. And here's the question. It says, find the magnitude and direction. So in other words, find the vector. And direction of U cross V, where U is 1, 1, 0, and V is 1, 1, square root of 2. All right, so we'll do that one. First, let's actually do it with in mathematical, so it gives us an idea of what it looks like. So we want the vector 1, 1, 0 is U, 1, 1, 0, and the other one we want 1, 1, square root of 2. So 1, 1, square root of 2. Here it is, and it looks like this. Right, so it's the, I should rotate it so that we have it more or less. And so the red one is the 1, 1, 0. I want the red one to be, okay, more or less like this. It kind of looks the correct way. So the red one is 1, 1, 0. The blue one is 1, 1, square root of 2. And then the purple one is the one we want to find out, right? We want to find out in which direction it points and how big it is. Okay, so there's the, let's see, 1, 1, 0 and 1, 1, square root of 2. So this time the blue vector is actually has a little bit of a height, right? So the red one has height 0. The blue one has a little bit of a height. It has height square root of 2, right? Okay, probably this is the better one. Okay, I want to find the better angle to show it to you, and you can see the markings of the X, the Y, and the Z direction. And I hope you can tell how the purple one is perpendicular to where the blue and the red are. Okay, that's the important thing. Okay, so let's now try to do it ourselves on the paper, see if we can figure it out. So first, you need to come up with a good drawing, right? So let's see if we can do that. So we want to draw these 1, 1, 0, 1, 1, root 2. So let's put our axis first. So I'm gonna make it so that so let's try the traditional ones. So remember, this is the X, this is the Y, and this is the Z. So first we want to locate the first vector, which is 1, 1, 0. That's not too hard, right? It's 1 in the X direction, 1 in the Z direction, and nothing in the Z. So it will be this vector right here. I'm gonna draw it black. That's U. Then we place V, and V is 1, 1, square root of 2. So 1, 1 is going to be this exact same one, but now we go up square root of 2, right? So it would be this vector over here. So this is V. 1, 1, square root of 2. Is that clear? So we go where 1, this is 1 and 1 is, and then we go a height of square root of 2. So then maybe this is not the best angle because we're sort of seeing it where the two vectors are, you know, squished one on top of the other. But maybe from here we can get the distance, right? So if we were to rotate this picture to the right, so to the right, this vector orange is on top of the black one, right? So if we rotate, so side view, let's do it like this, side view, we will have the u vector like this, and the v vector is exactly on top, right? It looks like this, right? And this one has, what is the length of 110? Well, it's 1 square, 1 square. So this one has length square root of 2. And this one has length square root of 4. So 2, right? And when you realize that, and that this is a right triangle, you realize that this is, the proportion is square root of 2 to 2. So that means this is a 45-degree angle. Right? We were lucky here that we sort of got an angle that we can recognize. So it's 45-degree angle here and there in both of them. So that's our theta. So our theta is 45 degrees or pi over 4. And that helps a lot because now we can calculate the magnitude of u cross b. So let's write it here. The magnitude of u cross b will be magnitude of u times magnitude of v times sine of theta. We calculated everything already. Magnitude of u is square root of 2. Magnitude of v is 2. And sine of pi over 4, which is radical 2 over 2. So this is radical 2 times 2 times radical 2 over 2. All right? One a sec. So the 2 cancels, and this becomes 2. So the new vector, the vector u cross v, is a vector of magnitude 2. And in which direction does it point? Well, like I said, so we need to go from u to v, right? So we're going from u to v, and then follow the right-hand rule. So u to v and the right-hand rule. So that means that that guy has to point in this direction, right? So it's a purple vector that is perpendicular to both. And since we're going from u to v, so it's like going from the black to the orange, right? From here to here, and then the thumb will be pointing in that direction. So is in this direction. So where exactly is it? Well, it's a direction in which is, so it's orthogonal to both, right? And this when we did the side view is like when we rotate 45 degrees. So this vector should be at 45 degrees in that direction, in the xy direction. The z, I don't quite know, right? And that's the thing. So getting the coordinates of that vector, the components, is actually something we haven't learned yet, right? We need to figure out how we will do it. So this is its magnitude. And to answer the part about the direction, so the direction of u cross b is perpendicular to both u and v. That's always the case, by the way. So if you ever want to find a vector perpendicular to two others, the way you do it, to find one of them at least, is to use the cross product. And so we have, so this picture gives you a little bit of an idea. And also, I mean, we have the other picture in Mathematica. Let's go back to that one. So the one that I was showing you in Wolfram, this one over here, right? Which I can rotate. That's the part that I like. So to make it match to the other one we had, it would be more or less like this, right? So this is the u vector. The purple one is on top. Like this is the side view that I was showing you before. You can almost see the 45-degree angle. And then the purple vector is coming towards us, and it's of magnitude 2, right? Yeah, from here you can appreciate it. So to match it with my first picture, it would be like this, more or less. All right? Okay. So so what have we gotten out of this so far? Well, first it looks like difficult, right? It looks like a difficult proposal to figure out what is the cross product. See, how are we gonna do that? I mean, if figuring out from the picture is gonna be close to impossible. So we need to find better ways, and those better ways um, have to do with knowing some properties, some specific properties. And thanks to these properties, we're gonna simplify considerably the way we can find the cross product. So here are the properties we want to know about. So here are the properties that are going to be important here. First of all, property number 1 here. See, we talked about this last time briefly, and I showed you already on Mathematica what happens when you switch the order, right? When you switch the order, the magnitude is the same, but now when you use the right-hand rule, instead of going from here to here, point up, you go from here to here, point thumb down. So the direction is exactly the opposite. If you flip, you change the direction. So this property is true. U cross V is minus V cross U. If you flip them, you pay a negative sign. All right? Scalars. If you have scalars A and B, so if you make a vector bigger or smaller, when you do the cross product, the direction is still the same. The only thing that's going to change is the magnitude of the answer. And the magnitude of the answer will simply be multiplied by whatever scalar you multiply by. So if you multiply by a scalar A or by a scalar B, the answer will be multiplied by A times B. That's what it says. And then we have these 3 and 4, which are actually the ones that are gonna give it to us. Okay, now unfortunately, we don't have the time or the bandwidth in this class to explain why this property is true, but it's actually a nice thing that it happens. So the distributive property is true for cross product. So if you do the cross product of U with a sum of 2 vectors, you could do the cross product with the first plus doing the cross product with the second. And it doesn't matter in which, if you do U cross V plus W or U plus V cross W, both of the distributive properties work. All right. So that's everything we're gonna need. And so let's do this example number 2, and that's gonna be part of our explanation of why everything works out. So for this example number 2, we want to do the cross product among the coordinate unit vectors I, j, and k. Now remember that these vectors I, j, and k are the ones that have 1 in the x coordinate, zeros in the others. J is the one that has 1 in the y coordinate and 0 in the others, and k is the one that has 1 in the z coordinate and 0 in the others. All right, so I'll show a picture in just a moment. Before, let me move to the next page. Let's see if it loads it while we do our exercise. Everything is going too slow. Okay, so let's do our picture. So for our picture, I need to draw I, j, and k. So here are my coordinate axes. This is the x, the y, and the z. And like I was telling you, so the I, the j, and the k are these vectors. So the one that points in the x direction of length 1, so this is 1, 0, 0, that's I. The one that goes one direction in the y, so that's 0, 0, 1, that's j. And the one that goes one direction in the z coordinate, that's k. All right, so these are I, j, and k. And the reason these guys are so awesome is that you can write any other with I, j, and k, right? So for example, if you have a vector 2, 3, 4, well, that's the same as 2 times 1, 0, 0 plus 3 times 0, 1, 0 plus 4 times 0, 0, 1, correct? And that's nice because this is 2 times I plus 3 times j plus 4 times k. So we can write everything with ij and k. That's the reason we want to do ij and k. Okay, so you ready, guys? Let's see if we could do them. So first of all, what would be I cross? So let me start with one that it's maybe you didn't think about. Well, so what is I cross I? We multiply I with itself. What do we get? We went over this already.
You get 0 since
You
it's
get the
parallel.
0 vector, right? These two are parallel. It's the same vector. And if you do anything with two that are parallel, in particular with two that are the same, you get 0. So that's correct. That's the 0 vector. All right, so that was easy. Now let's continue on our list. So the next one in our list would be I cross j. So what happens if you do I with j? So we're going from I to j. So which direction is it gonna point? If you do the right hand and you go from I to j, in which direction will it point? This is an easy one this time, right?
Maybe k.
Yeah, it points in the k direction, right? So I can't really show it to you, but so if I go from, you know, from I to j, right? From I to j, and then I'm pointing precisely in the c direction. So the direction is the direction of k. And what is its magnitude? So let's do the little work here. So what would be the magnitude of I times j? I cross j. Well, according to what we learn is the magnitude of I times the magnitude of j times the sine of the angle between I and j. What is the angle between I and j? What is that angle?
90.
90 degrees, right? Pi over 2. So it's times sine of pi over 2. And this is nice because everything here is 1, right? This is 1, and that's 1. So the answer is 1. So look at this vector. This vector is a vector of length 1 pointing in the direction of k. Which vector could it be? Well, it is k, right? There's no other choice. So I cross j is actually k, right? Is that clear? And this is kind of neat because it allows us to do a few others in a similar way. So of course, j cross j will be 0, and k cross k will be 0. That's the same thing, right? Two vectors, any vector with itself, you get 0. But now, what happens if I do j cross k? Let's try to figure that one out. J cross k. So first of all, the angle between j and k is also 90 degrees, right? And so is the angle between any three of them. That's the important thing here, right? The angle between I and j is 90 degrees, between I and k is 90 degrees, j and k is 90 degrees. They're all 90 degrees. So if I do the magnitude of j and k, we're gonna get, again, over here, magnitude of j, magnitude of k, sine of 90 degrees, sine of pi over 2. So the answer will be 1. So this vector will be of magnitude 1. And now, in which direction will it point? Well, I'm going now from j to k, and now I'm pointing in the direction of precisely I, right? In the x positive direction, correct? So j cross k is actually I. Easy. And by the same reason, if I do k cross I get j. So it's neat, right? It's kind of like a rotation, right? If you go from I to j, you get k. If you go from j to k, you get I, right? And okay, so we're essentially done. The only one we didn't do is this one. What about I cross k, for example? How can we get that one? I cross k. And this time we can use the rule that we talked about, right? We can flip it and pay a negative sign. And if we flip it, if we do k cross I, then it's already here. K cross I is J. So this we can flip it, and so we get negative J. And then the same here, if we do J cross I, we flip this one, so it's negative K. And if we do K cross J, if we do K cross J, we flip this one, what is it? This one, and we get negative I. All right? Is that clear? So this is like your multiplication table of cross product with your three basic ones with I, J, and K. So important. And let's see if I have it in the book now, and I can show you. Yeah, it actually worked. That was a good thing. So here is the little diagram you could use to remind yourself. So this circle one that you see on the right side is the one that can remind you how to get the ones we just did, right? So it's a circle. Put them in alphabetical order. So I, J, K, and then you multiply in the counterclockwise is positive, right? Counterclockwise is positive. And then in that way, if you want to do I cross J, you get K. J cross K, you get I. So you do 2, and then you get the next one, right? If you're going to go the other way around, you pay a negative sign. That's the only thing you need to remember. And here are the other ones, right? So K is I cross J, but it's also the same as negative J cross I. And here's a summary of the ones we did, right? So this is this little theorem 13.5 has all the ones we did right now, including the ones when you take one number with itself. So I cross I, J cross J, and K cross K, you get 0. All right? Okay, so I think we're ready. Believe it or not, we're ready now to try to get a formula to get the cross product of arbitrary two vectors, right? So let's do it. So let's see if we can do the cross product of two arbitrary vectors. So we want to do the cross product of, I'll write it here, calculate, switch to the page. So we want to calculate the cross product of, calculate U cross V, and here are U will be U1, U2, U3, any numbers, and V will be V1, V2, V3. All right, that's we're gonna do it in general. All right, here we go. Let's do it. So the first thing we want to do is, instead of writing U and V, we want to write them with I, J, and K. So instead of writing it like this, we're gonna write U1I plus U2J plus U3K. Cross product V1I plus V2J plus V3K. That's step number 1. Step number 2 is we're going to use the distributive property. So we're going to do this cross the first, plus this cross the second, plus this cross the third one, right? Like foiling it. So it will be this one. It's a lot of writing here. So I'm just writing the first one times the first plus the same one times the second plus the third one. I mean again the big term with the U's times the last one, which is V3K. All right. It's not fitting the entire thing. Let me move it a little bit higher up. See, good. Okay, so next, again, we use the distributive property, right? So this times that. So that's going to be, here we go, U1, V1. That's the constant, and then it's I cross I. plus U2 V1, and it's J cross I, plus U3 V1, and now it's K cross I. And I'm not writing the arrows on top of it because then it's just gonna look clunky, but you know these are vectors, right? The I, J, and K, you know they are vectors. So I just did these three. I'm gonna write the others in the bottom so that it also looks a little bit cleaner. So the next one will be U1, V2, and it will be I cross J. The next one will be U2, V2, and it will be J cross J. And the last will be U3, V2, and it will be K cross J. Good, so I'm right here. And then this last one, okay, so now it's U1, V3, and it is I cross K, then U3, V2, and that will be J cross K, and last U3, V3, K cross K. All right, you with me so far? I mean, it seems like a lot of calculations, but they're actually all pretty easy and straightforward, okay? Now, here is where we're gonna use what we just learned, right? Remember, let me do my little circle here. So we have I, J, and K. And if you go like this, you get the next one. And if you do it with itself, it's 0, right? So that's good because we already, these guys are 0, right? They don't mind. And then the other ones, well, we can simplify them. Let's see. So this will be J cross I. J cross I, we go in the opposite direction. So it's negative K. So that will be U2 V1 times negative K. Plus K cross I. K cross I is J. So that's U3 V1 J. Plus I cross J, that's K. Good. Then K cross J goes in the opposite direction, so it's negative I. Then I cross K also in the negative direction, so it's negative J. And last, J cross K, which is I, so that's U3 V2 I. All right, we're almost done. Now I'm just gonna collect the I's with the I's, the J's with the J's, and the K's with the K's. So here are the I's. So it's going to be U3 V2 minus, hold on a sec, this is U3 V2, and this was, there's one here that is not quite right. Let's see, I shouldn't be getting the same one. So let's see, where is this one come from? This one comes from this one, which has a mistake, right? This should be a V3, U2 V3. My bad. So let's fix this one. Yes, so this one came from here, U2 times V3, right? U2 times V3, so this one should be U2 V3, and that will corresponds to this one, U2 V3. All right, so it should be U2 V3 minus U3 V2, and that's the I, right? Then what about the J's? The J's, we have this one and that one, and these are U3 V1 minus U1 V3. Notice how like the symmetry feels kind of nice, right? So it's the index of the U3 and V1, and then you change U1 V3. And then for the K, we have U1 V2 minus U2 V1. Okay. All right. So that's it. That's a formula. That's how we get it in general, right? So from here, you can write it then without the I, the J, and the K. You can simply write it like this. But you don't want to do this. We actually like the I, the J, and the K because of the following. Because you can write it using a determinant, right? And if you remember from your pre-calculus days, how determinants are done. If you don't remember it, I'll remind you in just a moment. But you can do the following matrix. So this is how we can, summarize and, write something concise about what the answer would be. So we have U cross V is this determinant. You put I, J, and K on top. Then on the second row, you put the U. So U1, U2, U3. And on the third row, you put the V's. That's a and this means determinant. And the way you do a determinant is you take any row. The best way here is to take the top row, and you take this one, is I, times this little determinant, which is U2, U3, V2, V3, minus. When you go to the next one, you change the sign. You always change the sign when you go in a determinant like this. You go to the J, and then for the J, you cover the J column and you cover the row that you are, and whatever remains, this U1, U3, V1, V3, that's what you put here. So this is U1, U3, V1, V3. Is that clear? Then with the K, you cover the column, you cover the row, and whatever remains, that's the little one you're gonna put here. So it will be U1, U2, V1, V2. And then the way you do these ones is super easy. So you want to do A, B, C, D. What you do is you multiply these two and you subtract these two. So it's AD minus BC. So multiply these two minus these two. Multiply these two minus the product of these two. Multiply these two minus the product of these two. That's how it works, all right? Now there's another way of doing it. If you don't like this, there's a second way. The second way is that you copy the two rows, copy them again here. So copy the first two rows, I, J, K, and U1, U2, U3. And then you go like this. You go by diagonals with positive signs. So this will be I times UTV3 plus K times U1V2 plus J times V1U3. And then you do minus, and now you go over the opposite diagonals, these orange ones. So you do minus, and now you do the orange ones. The orange ones are U2V1K, V2U3I, and U1V3J. All right. Either way, whichever of the two you prefer, either way, it gives you the correct answer, and it is a shorter way instead of trying to remember this long formula, right? But now you can check how. See, for example, right here with the I, if I do this little determinant, it would be U2V3 minus V2U3, which is exactly what is written right here. U2V3 minus U3V2. So that makes it so how this expression matches this determinant over here in the bottom, right? In the same way that this one matches that one, right? So this is exactly the answer to this. This is the answer to this one. And this purple one is the answer to this one, right? So this is like a short, compact way of knowing what it is. All right. Okay, so this is probably a good point to stop. We'll do problems about specifically calculating the dot products and how it relates. So the dot product, the cross product, I meant the cross product. The cross product is great when we have questions of the following type. Like calculate a vector which is perpendicular to two others, right? I have two vectors somewhere there, and I want to find out the other one that happens to be perpendicular to the two that I had originally, right? One that is the green one that is perpendicular to the other two. How to do it? With a cross product. And it also is helpful to calculating areas of parallelograms, right? Sometimes in an indirect way, you can get an area. If you want an area of a parallelogram in 3 space, you can instead calculate the cross product and then take its magnitude, because the magnitude will be the area of the parallelogram. So those are the types of questions we're going to be doing, all right? Okay, so we'll continue tomorrow. I know this was, I have to check exactly what was happening with my computer, because we had some glitches here and there, but at least I could show you those pictures in Mathematica, so you could more or less get an idea of where the cross product is in relation to the other two. Okay. Are there any questions before we sign off? Okay, very well. I'll see you guys then tomorrow. Stay safe.